Hi, welcome to reInvent 2020. My name is Balaji, and I'm going to walk you through best practices for securing your multi-account environments. Today, I'm going to be talking about multi-account architecture. I'll have a short intro for you, but if that is not enough, I do have some resources towards the end of the slide deck where you can learn more about our multi-account guidance. But the focus of our conversation today is going to be around AWS Organizations, a service that supports multi-account environments and the security features within that service. In fact, I've picked out 5 features that I think a lot of customers who have had good experiences in their multi-account journey have used quite successfully. And these 5 features will walk us through how to create accounts and group them, what kind of security services you're going to need to begin your journey, and how to use organizations to enable them. We'll talk about how to deploy resources and have an example of a resource. We'll talk about enforcing controls via organization policies that control how some of these resources that you deployed are going to be tagged and backed up, etc. And then we'll talk a little bit about how to manage user access and how to share resources securely between the accounts in your multi-account environment. So for a quick 2-minute recap of why customers use multi-account environments, put yourself in the place of a cloud operations group in a company. You have different teams within your company who want to use AWS services. The easiest way in which to enable these teams is going to be to give them access to an AWS account. And then they will be able to go out and experiment and innovate on behalf of your company and create business value. And these accounts are exclusive in that one team's account will not interfere with another team's account resources. They are also an explicit security boundary. And when you have multiple accounts, you can group them together based on your operational needs, such as a production account, and group all dev accounts together, and apply specific security controls and other controls based on your organizational needs. A very nice feature when you use multi-accounts is the ability to assign costs based on who is operating a particular AWS account. This allows you to do chargeback and other mechanisms for internal cost management. So AWS Organizations is the service that supports the underlying infrastructure and capability for all multi-account environments. You will probably come across a lot of multi-account solutions and architectures that are built on top of organizations. Today, we're going to talk only about native organizations features, but we'll talk about one AWS service which also is built on top of AWS Organizations and supports multi-account environments. To give you an indication of how widespread AWS Organizations is used, over 90% of enterprise customers use AWS Organizations to support their multi-account environment. And if your company uses a feature called consolidated billing, whereby you get an aggregated view of the costs incurred by every account owned by a company, then you're already using organizations. So since that is out of the way, what kind of features organizations provides to support multi-account environments? You can programmatically provision new accounts. You can implement security controls and enable audit management capabilities for all the accounts in your environment. You can share resources, control access to different things like accounts, regions, and AWS services. You can optimize costs by leveraging AWS credits and volume discounts across all the accounts in your organization. Now, all this multi-account goodness has to come via AWS Organizations. But first, there is a step that you must remember. I'm not going to have a slide on that, but if you intend to use AWS Organizations, look at how you can enable Organizations all features mode. And when you say all features, it takes Organizations beyond the consolidated billing mode and allows you to leverage all the cool new features that we're going to be talking about today. So I will assume that you've enabled Organizations in all features mode and go directly to the 5 features that I like. So as you start your multi-account journey, before you create accounts and hand them over to your application teams, you're going to want some kind of structure in which to lay out these accounts. So how will you do that? The concept of organizational units is a organization's concept that is a container for accounts and other OUs. So you would want to create an OU structure that reflects multi-account best practices. If you don't know what those are, I have a link at the bottom of the deck. And you can also do a quick search on our public pages to understand what multi-account best practices are. So one of the first accounts we see customers creating is that of a security organizational unit. And under that OU, we will see a child OU or a nested OU to group all the accounts related to production security workloads, and a security beta OU that groups all your dev and test workloads. So we have an account structure now, or an OU structure. And within that OU structure, we create a first account in the beta OU, and that account is going to be used to test IAM policies, security automation, or any such tools that you want to implement in the rest of your environment. Under the security prod account, we typically see 4 accounts, and these 4 accounts are going to be a security read-only account that is a container for all the roles that have read-only permissions to all the other accounts in your environment. The security break glass account is going to host all the IAM roles that have privileged access and are used to recover and respond from security incidents in your environment. The security break glass account is typically not used on a regular basis, but only used in the case of emergencies. The security tooling prod account hosts management capabilities and uses to run tool sets such as firewall management capabilities or threat detection capabilities that are deployed in all the other accounts in your environment. The log archive account is a specialized account that acts as a repository for all the data stores that host audit logs in your environment. Now, the log archive account should not host any services normally. So we have our OU structure and we have some accounts to play with now. So what next? The next step would usually be to look at what other security capabilities are you going to need in your multi-account environment. AWS supports more than 10 different security services that are integrated with organizations. Now, each of these services has a different operational impact. It changes how your security process works. It may enhance or do away with some other tool that you have in your on-prem environment, or it may complement an existing capability that you deliver out of your on-premises environment. So you would normally go through a planning exercise in order to determine which of these AWS services make sense for you to turn on. There is, of course, a cost impact to each of these services, and so you'd want to take a look at that as well. Services such as Guard Duty provide threat detection capabilities in your multi-account environment. Amazon Macie is a privacy offering that allows you to discover and protect sensitive information in the data stores in your multi-account environment. IAM Access Analyzer looks at the resources in your accounts and determines which ones have external access. Firewall Manager allows you to centrally manage web application firewall roles. AWS Config provides detective and corrective capabilities for automating security controls at scale. And there are many other services that you will want to look at as you go through this process. One of the aspects of centralizing security is that there should be a special place or a specific place where these tools operate, and that is the security tooling product account that we talked about earlier. Organizations supports the concept of delegated admin, where these tools are going to be operated out of the security tooling product account, and organizations allows you to delegate the management of these services to a specific account within your organization. That ensures that the management account is used for very particular and specific needs that can only be done from the management account. The management account is a special account in the organization's hierarchy and has some capabilities that should not be operated on a regular basis. And that is why we delegate the management of security tooling to a separate account. So we created some accounts and we've looked at how we can go about enabling some security tooling. One such integrated service is CloudTrail, which records users, any actions taken by a user, role, or service role, and records them as events in a log trail that is then stored in a S3 bucket. When we use organizations to enable CloudTrail, this organizations trail is usually stored in the log archive account that we created earlier. And this log archive bucket, because we created with organizations, has some special protections. Organizations also put some controls in place to ensure that the CloudTrail in these member accounts is not tampered with or deleted. Organizations also ensures that when a new account is created within this organization, the CloudTrail is automatically enabled and pointed to store its logs in this bucket. So as you deploy, now that we have seen how to enable security services in the account structure that we created, what do we do next? Typically, security teams would want to have some visibility into the accounts that are being created and the resources that are being deployed in those accounts. In order to facilitate that kind of visibility, we are going to need a read-only role. And organizations integrates with AWS CloudFormation, specifically stack sets. And with this feature, you can create a template in CloudFormation, which is infrastructure as code on AWS, and deploy it from the management account via stack sets and roll out that template to all the member accounts and have a role to be used whenever it is needed. Now you will notice that organizations and stack sets together enable you to have that role deployed in any new accounts you create as well. So now that we have visibility into these accounts and we have the account structure that we created earlier, we're going to have to check if we're ready to have developers and application teams on board to our AWS accounts and start deploying resources and applications. We might want to have one additional step before we do that. And that step is going to be policies that ensure that there is some consistency in the resources that are getting deployed. Organizations supports 4 types of policies. Backup policies, which can be applied at the root level or at the OU level or at the account level, and in aggregate, it will ensure that you have fine-grained control over your backup plan and ensure that it meets your disaster recovery requirements. Tag policies also ensure that there is some consistency when different teams start operating in these environments in the tags that attach to their resources. AI service opt-out policies will help you centrally mandate what kind of interaction our artificial intelligence services have with the data in your account. Service control policies, the last type of policies that organizations support, are a special case, are a favorite for a lot of our customers because they allow you to set guardrails in each of these member accounts. Service control policies control the maximum available permissions for your AWS accounts. But the important thing to remember is service control policies are also apply to the root and any user or role in those member accounts. So that means if your company does not operate in certain AWS regions or does not want certain AWS services to be enabled in their accounts, they can do so very easily by applying a service control policy on those member accounts. Another type of use case for service control policies is to protect certain services that are important to your company. For example, the log archive bucket that we talked about should never be deleted. And so service control policies are applied for those kind of resources. A good example here would be the IAM role that we deployed earlier. That IAM role can be modified by any member account role or user that has permissions to IAM, to modify IAM resources. And so in order to make sure that doesn't happen and that we always have visibility into those environments, a service control policy such as the one that I have for you should be applied either at the root level or at specific parent OU level. And from there, it will be inherited by all the accounts under that tree structure. So we've now finally reached a place where we have everything we need in order to provide access to the developers and have them deploy the resources and workloads on AWS. AWS Single Sign-On is a service that helps you do that at scale and efficiently. It allows you to create permission sets related to job functions, and it integrates very nicely with your on-premises identity systems. Once these application teams and developers start onboarding to these AWS accounts and they start creating resources, they will notice that some resources are duplicated and they will want to share these resources. And AWS Resource Access Manager allows you to do that in a very easy manner and a scalable manner. It supports some of the most commonly shared resources, and there is more resources that are going to be supported by Resource Access Manager in the coming months. So what did we look at today? So we looked at how to create an OU structure. We put some accounts together. We put some accounts under the OU structure. We enabled a security service, talked about the considerations that go into choosing the security services you want to enable. We looked at how delegation of administration is a feature that can support your separation of duties requirements. We looked at how to deploy a read-only role across multiple accounts and how to protect that role with a service control policy. We looked at some other policies such as tag and backup policies as well. And then finally, we talked about managing user access and how resources can be shared securely in your multi-account environment. So what's next? Where do we go from here? Organizations also supports the concept of service limits, which I encourage you to look into. Service limits, otherwise known as service quotas, are mechanisms by which there are some default limits on the amount of resources you can consume in a single account. And service quotas allows you to automatically request increases and enforce certain templates on what kind of resource should be consumed within those member accounts. You can also apply certain billing and cost controls via some of the tools in AWS Organizations. But Organizations offers a lot more in terms of capabilities for management and governance. And because it offers such a wide and rich variety of capabilities, some of our customers have come to us and said they want some additional guidance in how to build and operate their multi-account environment. And for those customers, we launched a new service called AWS Control Tower. Control Tower is built on top of Organizations and abstracts some of the features that we talked about today to provide a prescriptive and guided way of managing your multi-account environment. So I have some best practices here for you. I encourage you to read through our multi-account guidance and organizational best practices. And with that, I want to thank you for watching me today, and I hope you enjoy the rest of your reInvent.